Reviewing our quiz from a couple weeks ago, what two things do you need to write a line? Every single time you should be thinking this. The two things that you need are the slope and the y-intercept. This first question is nice because I give you all the information. I give you that the slope is negative 1/4. I give you that the y-intercept is negative 12. So there is no calculation whatsoever. Our slope is negative 1/4. Our y-intercept is negative 12. So our final answer needs to be written as an equation of the line. So y equals negative 1/4 x minus 12. What two things do you need to write an equation of the line? You need the slope, you need the y-intercept. I gave you both of these pieces of information. They just come in the form of a graph. The y-intercept is probably the easiest to recognize. It's where our line physically crosses the y-axis, so it crosses at negative 2. Our slope, we have found the slope a lot this year. That is our rise over our run. So I'm going to count from coordinate to coordinate. I rise up 1, 2, 3, 4 units. And I run 1, 2, 3 units. I am going to the left, so that does make it negative. So my slope is negative 4/3. My y-intercept is negative 2. I am not done though because they want an equation. So my final equation is y equals negative 4/3 x minus 2. What two things do I need to write an equation of the line? I need the slope and I need the y-intercept. Unfortunately, I can't find the y-intercept from this picture, and the slope is a little bit hard for me to count between spaces, so I am going to use my slope formula. So if we're not given any information, just like what we talked about in class today, we're going to start with the slope. So my slope is y2 minus y1 over x2 minus x1. I'm going to label my coordinates to make it easier to substitute. So I'm going to make this my first coordinate and this my second coordinate. So as I substitute in, my y2 value is negative 3, subtract y1, which is 3, over my x2 value is 5, subtract my x1 value, which is 3. So simplified, negative 3 minus 3 is negative 6. 5 minus 3 is 2, and that reduces. Negative 6 divided by 2 is negative 3. So my slope is negative 3. So now that I have my slope, I'm going to go into my equations. Some of you prefer y equals mx plus b. Some of you prefer point slope. Go with the one that you like better. So I'm going to choose the coordinate 3, 3, since they're both positive. If I am a slope-intercept person, and I'm choosing the value of 3, 3 for my x and y, and I already found my slope was negative 3. So my y value is positive 3, my m value is negative 3, my x value is positive 3. I'm solving for b. Negative 3 times 3 is negative 9. I add 9 to both sides to get a b value of 12. So at that point, I can write my final equation, y equals negative 3x plus 12. If you prefer point slope, we'll have y minus 3 equals negative 3 times x minus 3. We distribute this through, so we get negative 3x plus 9. Then to isolate y, we add 3 to both sides. Still get that final line of negative 3x plus 12. What two things do we need to write a line? We need the slope and we need the y-intercept. I actually gave you the y-intercept. Remember, these are just fancy coordinates in disguise. So that is the coordinate 0, 2, and I also have the coordinate 3, negative 1. If I were to plot this just to show you, 0, 2 is on the y-axis. 3, negative 1 is just another point. So I did give you the y-intercept. The y-intercept was positive 2. I did not give you the slope, though. So we're going to have to use our slope formula again. I'm going to label my coordinates to make it easier to substitute. I'm going to make this my first coordinate and this my second coordinate. So my y2 value is negative 1 minus my y1 value of 2. x2 value of 3 minus x1 value of 0. When I simplify, negative 1 minus 2 is negative 3 in my numerator. 3 minus 0 in my denominator is 3. Negative 3 divided by 3 is negative 1. Slope is representative of the letter M. So now that I have the two pieces of information that I always need, I write my final line, y equals negative 1x plus 2. Now this final question had a lot of pieces and parts to it. So the table shows the distance covered by a spaceship in outer space. Can the situation be modeled by a linear equation? So that means, does it have a constant rate of change? So I'm looking. My x values are increasing by 3. My y values are increasing by 15. So to answer part 1, the answer is yes, because it's a constant rate of change. Part 2 then asks you to write a linear model. So what do we need for a linear model? We need the slope and we need the y-intercept. Well, the slope is the change in y over change in x. My y is changing by 15. My x is changing by 3. 15 divided by 3 is my slope. I have 5 different coordinates that I can choose from to go into my equation. So I'm going to choose the coordinate of 1, 5. And I'm going to plug into y equals mx plus b. If you prefer point slope, then that's what you're going to plug into. So I have a y value of 5, an m value of 5, and an x value of 1. 5 times 1 is 5. I subtract 5 from both sides to get a b value of 0. Now that I have my slope and my y-intercept, I can write that linear equation or the linear model of y equals 5x plus 0. Then it asks, what does the slope represent? My slope is 5. what does that mean in terms of this problem? Well, it means that this spaceship, so the spaceship travels 5 miles per second. It's representing the spaceship's speed. What does the y-intercept represent? Well, my y-intercept is 0. So that represents my spaceship's starting distance. So that means it's starting at 0 feet.